Okay, good morning, everybody. Thank you for joining. We are going to give people a couple more minutes to get their virtual chairs set up for this webcast, and then we are going to get going. So give us a couple of minutes, but we're glad you're here. And even before we get started with the actual presentation today, feel free to hit the questions box on your right and put any questions in that you have that you want to get addressed during this webcast. We do this presentation quite often, so this is really for you. We want to make sure you get the most out of it, so go ahead and ask any questions and we'll get them addressed, not just at the end, but as we go through the course of the presentation. So just 2 minutes here and we'll get going. Thanks very much. Got a very, very complicated question to start us off, which is, who is Datera? I guarantee you we are going to answer that question during the course of this webcast. So no problem. Keep coming with more questions. Oh, I see a few more coming in. Here we go. Good. Okay, one more minute and we will get going and we will make the best use of your time. And the way to make the best use of your time is for you to put in as many questions as you have. I guarantee you this stumper that I see right now, who is Datera, and the next one that I see of what are the prime use cases that we need to be thinking about if we were to adopt a software-defined storage offering. We're going to go through those, but keep those questions coming. Okay, with that, to make the best use of your time, I think we're going to get going. My name is Chris Cummings, and I'm responsible for go-to-market here at Datera. And for this webcast, we're going to be focused on the next generation software-defined data center, what many have been calling the SDDC, including our friends over at VMware that we're partnered with. They've been talking about this now for a decade. It's been interesting to see that some people have achieved it, some people haven't. And a couple of folks that have been working in this area to help large enterprises actually achieve the software-defined data center and define what a next-generation architecture looks like for their data are Don Molaro, who's Chief Technical Advisor at Worldwide Technology, WWT, very well known in the industry. So thank you, Don, for being on today with us. Really appreciate it.
Thank you.
And also Hal Woods. Hal is CTO here at Datera, who thinks a lot about where the industry is, where the industry is going, and what is needed from a requirements and what's really needed out with our customers that we're talking to every day. So Hal, thank you for being here.
Glad to do it.
And we unfortunately were not able to be joined by Bill Borsari, who leads our one of our field technical leaders out there. He is in frozen Minneapolis this morning and not quite frozen Chicago this morning with several of our customers, so he was unable to come, but we're going to do our best to inject some of his thinking here in terms of what he's seeing out there in the customer base. So with that, I think we're going to push forward here and get going. If we can move to the next slide, please. What we're going to do is we're going to start with Don and have Don talk a little bit about what he's seeing out there, because he's thinking beyond just storage. He's looking at the entire complexity of the data center and what's changing and what needs to be thought about. He's been both as an advisor and also been, on the inside of large organizations. So Don, I'm going to turn it over to you. Thanks again. Thanks a lot, Chris.
So for those of you not familiar with WWT and sort of the role that WWT is playing in the industry, we're one of the very large systems integrators really worldwide. But what we find more and more is that rather than just providing particular pieces of equipment or supply chain optimization, is many of our customers are turning to us because we have such broad expertise and essentially broad exposure across the industry, turning to us in an advisory role and asking and working with them on architecture, and as they re-architect their data center towards a software-defined data center, what does that look like, and sort of what are the best practices in the industry? And really what I'm showing on this slide is an aspirational architecture that we see emerging. Really the fundamental nature of this is that we're moving, I think the realization is coming along that we are moving away from an application-centric view of the data center where people and users are concerned about their applications to being more concerned about how to make their data available to applications universally and in any location that they happen to be running in. One of the architectural trends that we do definitely see is the movement to multi-cloud architectures, whether that's hosted on private infrastructure, whether that is present on public cloud infrastructure, or whether that is in a third-party hosting environment. So let's move ahead one slide. So this is an application. This is a use case that we've seen where rather than when you're going to do an application migration from an on-premise infrastructure to a public cloud infrastructure, how to make that move. And quite often when we deal with customers who have tried this, they've tried the traditional lift and shift approach, which is they take their application, they refactor it so that it can be moved to a public cloud environment, and almost as an afterthought, move the data associated with that application. And what I counsel our customers on is that that's perhaps the incorrect approach, which is to first think about the data and think about all the dependencies in the data and essentially how to abstract the data plane, and then refactor the application against that data plane before it can be moved. This allows not only the application to move between data center environments, it actually allows the application then to be properly bursted between public and private infrastructure. And clearly the data abstraction level and the data mobility level becomes a key part of the architecture for that.
Yeah. Hey, Don, before we leave this, and this is a great sort of kind of overall, I wouldn't call it a reference architecture, but topology of how this is working. What's the state of play that you see? Because, every one of the people that's on this, including me, sees private cloud adoption this and multi-cloud this and that. Where are these, large organizations currently in their state of adoption?
So I think certainly we have yet to see, with one notable exception, which I won't comment on. Every single organization we deal with has a multi-cloud strategy right now, or is working on one. They are recognizing that some of their workloads will be on-premise, and they will be on-premise forever, and some of their workloads belong in public cloud. And there's a really large amount of re-architecture work being done around applications and data, everything from on-demand DR environments being spun up in clouds to dealing with bursty applications. I think it's incumbent on every organization to recognize that certainly in the next 5 years, in the same way that right now we're seeing cloud adoption, I think in 5 years I think it'll be I think it'll all be about multi-cloud and sort of having a strategy that stretches across these three environments.
Got it. So people are really defining this now. They may be moving down the path towards implementation, but it's got to be in their thinking process as they reset their environment. That makes sense.
Absolutely.
Okay.
So Don,
great.
what I really like about this slide is the little graphic you have in the upper right, which provides some guidance about what data, the persistent data, perhaps in the private infrastructure, and maybe a copy of some of that data up in the public cloud, based on kind of what the workload looks like and that sort of thing.
Well, and I think, but there's the persistence of the workload is one issue, and its size is another. But quite often, like I tend to work a lot with highly regulated industries, so either healthcare or financial institutions. And this is a lot more than a two-dimensional discussion, right? This ends up being a 3 or 4 or 5-dimensional discussion because you have data sovereignty issues. You've got regulatory, various different regulatory overlays on where and how particular workloads can be run in what environments and under what conditions. So this is a bit of for simplistic workloads, absolutely, scale and persistence is sort of a key deciding factor on where to run it. But of course, in the real world, things get very, very complicated.
Absolutely. Yep.
Okay, let's move on. This slide didn't come out quite right, so please excuse me for that. But what I tend to, the other industry trend I see is, of course, every organization thinks they're special, and they are in many ways, but they're probably not as special, quite often as special as they think they are. And we see, really at the very top part of an organization, and I'll use a financial institution as an example, there is a relatively small amount of data and workloads that are fundamentally business critical. A trading floor at a large financial is part of its absolutely most critical infrastructure. And it is incumbent on them to make sure that is absolutely reliable, absolutely perfect, and is extremely performant. And of course, at the other end of the infrastructure, they undoubtedly have, some legacy gear that they have a migration or a minimization or a modernization plan around to move it, to reduce its impact. And then the bulk of the data and the bulk of the work that they do fits into the middle part. And the reality of that is that's pretty much the same as every other organization. And those are the kinds of workloads that we see and that I believe really belong in that software-defined data center, because it has to be delivered. It has to be delivered at scale. It has to be delivered economically. And it has to be delivered not only economically from a CapEx point of view, but economically from an OpEx point of view.
Right. And I like that you've got the XO percentages. When you think about the customers you're talking to every day, and if you had to step back and generalize, hang on, go back, please. What percentage is in that middle bucket?
It really depends who you talk to. I mean, my looks about right estimate. I mean, I always think of that middle part as about 80% of the workload. But of course, your mileage may vary, and it depends who you talk to in the organization, because everybody looks at an organization from their own bias perspective, and I undoubtedly have my own bias when I talk to organizations as well. So it's really a question of who you talk to and sort of what is important to them from their perspective.
Right. Okay.
So Don, would you say that it needs to be boring? How are we doing on making it boring?
On the software-defined data center, it's a pretty exciting place to be. I mean, there's still lots of work to be done. There's lots of care and feeding of systems that need to be done. But we're making very good progress on it. Certainly, our joint colleagues over at VMware, our colleagues over at Red Hat, and people delivering the compute side of this organization of that software-defined data center are doing a pretty good job. And Datera is an example of a company that's doing a good job on the storage side. That being said, there are others. I mean, there's no shortage of effort being put into making that software-defined data center boring. And I mean, that's where we want to be. We don't want it to be the kind of environment that gets people up in the middle of the night to go fix things.
Right. Exactly. Okay. Keep going.
Yeah. So this is sort of my view of how over the next few years, how the data centers and the data in the data center is going to evolve. Really, we have this we have this concept now of hot and cold data, which I understand what people are trying to get to, but I don't think it's a very good distinction. And there's associated, there's the functions that run on hot and cold data, file and block and databases and analytics environments and object storage. And as the next refresh of technology comes along, and we move to all flash environments, either with 3D and multi-cell flash taking on the bulk storage role. We see NVMe over F and NVMe in general taking on the high performance persistent storage in a node, and the emergence of storage class memories. I think we're going to start talking about storage in different ways. We're going to talk about storage that requires deep integration into the operating system, like we're going to have to see in storage class memories and in NVMe over F. And then we're going to see storage that requires deeper application integration. And certainly the migration from systems that have traditionally been file system and databases into systems that use object storage are sort of the sort of next generation application change.
It's interesting. I mean, I came from that space, Don, and I'm curious about what you see being the future for object. I mean, when we get to talking a little bit about Datera, we'll tell you about what we do there, but just what are you seeing amongst the customer class that you're talking to every day in terms of object? Because we've tended to think of that as being cheap and deep, and we've also tended to think that that's the first place that gets adopted when folks go to move into the public cloud.
I think both of those statements are true, but I think there's a new class of object storage users. I'm starting to see the emergence of performance object. I came out in one of my previous jobs. I spent a lot of time doing supercomputing, and there is, this idea that object storage, and I was the architect for the object store for that company. The idea that object storage needs to be cold, or that it's strictly for data that is mostly dead, I believe is a concept that is falling away in the industry. We're starting to see high-performance object stores being stood up for analytics environments. We're starting to see high-performance object stores being set up as backup targets, which is because people are starting to realize it's not so much doing the backup that's the hard part. It's doing a very rapid restore. And the one thing you can do with an object store is doing parallel, high-speed parallel restores that is hard to drive through a tape drive. And so I think there are absolutely use cases that are emerging for high-performance object.
Yeah, that's useful. Excellent. Okay.
And this is my last slide. I've always been very bullish on the long-term prospects of software-defined storage and its adoption into the data center. And I know it's had a very hard road. I've been part of deployments that have been long, hard roads in order to get deployed. And I spent some time thinking about why that is. And a lot of it is because the initial adoption phase, the initial deployment phase, and the day one and day two operations piece of it is very difficult. It's easy to buy appliance-based storage, and you roll it in, you turn it on, and it goes. That's not the case for software-defined storage. It may, in fact, in the long term, once your staff comes up to speed, it may be an easier and better solution. But addressing that day one and day zero, day one and day two operations, that is a hard thing. It's a question of how do we get the software-defined storage industry, to this adoption tipping point where where both the deployment of it makes sense, or is just as easy as an appliance, and the economics make good sense. And so this is sort of this has been my call to the software-defined storage industry of how to make your products get to this tipping point and really bring that mass adoption that I think is important.
That makes sense. So let me drill in on one thing here. So it just, when you reflect back on what you expected and what you got, if you kind of divide up that economic argument between the CapEx side of the equation and the OpEx side, and what it took to operate the system, where was the letdown when you go back and look at what you were expecting and then what you ended up with?
It's shades of gray everywhere there. I mean, a lot of it comes down to the feeling is, certainly the original promise around software-defined storage was that you can deploy commodity hardware. It's sort of fundamentally cheaper than appliance-based storage, but you're going to potentially have a greater OpEx burden on top of it because you have to manage the hardware yourself associated with that. I'm not actually sure where the cost breakdowns and where the pain points are in that. I think those are all unique to every organization. A lot of this comes down to organizational change. A lot of it is dealing with organizations that have done done their storage and built their data center one way for a very long time, and this is a big paradigm shift. And so a lot of it is dealing with not only just the straight economics of it, but also dealing with the institutional change that's required.
Yeah. One question that came in that's related to this is just the topic of HCI. So, you know, a lot of adoption in the industry of HCI, and the big thing there is thinking that not only do you get the CapEx savings, but from an OpEx perspective, if you've got compute, storage, and networking in one box, and that's a generalist as opposed to a specialist in each discipline, you know, the question is really around, can you get the OpEx kind of advantages that you're talking about out of an HCI implementation?
I think you can get the OpEx savings out of a well-defined and well-executed system. I think it's whether it's HCI or converged infrastructure, or whether it's software-defined storage, or whether it's even appliance-based storage. A lot of it comes down. To me, the OpEx is all about how well the organization can run it, and how well the organization is prepared for change. And I mean, frankly, that's a bit of a dodge of your question, but to me, you know, a very wise friend of mine said, you know, it's, you know, as much as we as engineering people like to talk about the technology, most of the issues that we see in organizations are people related, and it's really when WWT goes into a customer and talks about transformation, we spend at least a third of our time talking about transforming the workforce, and transforming the approaches to problems, rather than saying, here's a shiny new widget and this, you know, this is a great widget. I mean, we spend a lot of time working with and on organizational change.
Got it. That's useful. It is a change. This is very different, because I came from the array-based business for, you know, 15 years, and it's a total paradigm shift. You're right. Okay.
So what, you know, Don was talking about is SDS being, you know, very difficult. You know, this is my, so working at Datera, this is my 16th, what would be now termed as SDS architecture that I've seen. And so, you know, been at this about 30 years. And when I came to Datera, it was because I think they got it right. And the reason I think they got it right is their goal was not to say, I want to replace an appliance-based storage system. The goal was, I want to fit into a software-defined data center. And so over the next few minutes, I'll talk a little bit about you know, what that means, what that software-defined data center means, and how SDS, you know, to Don's, you know, kind of notion, how we can be boring, given that the software-defined data center is very much always in flux because of the nature of the businesses that use it. So what are some of the challenges of the software-defined data center? So if you go to Google or your favorite search engine and type in a data center, what you will come up with is images of racks of servers in rows of racks. And the problem is that's a very hardware and infrastructure view of what a data center is. And the data center is really about the data. And Don illustrated this in a number of different ways about a data management layer. It's abstracted from the applications, it's abstracted from the infrastructure. You know, today data is everywhere. It's on the edge, it's in the cloud, it's on-prem. Many different applications are often accessing the same data, and they generate new data and new metadata when they do that. An additional thing is data has gravity. Don pointed out data is difficult to move around, sometimes because of its mass, sometimes because of regulatory reasons. More and more we're seeing applications moving to the data as opposed to the data moving to an application. The software-defined data center must support current and future applications, and to a certain degree legacy applications, because today's current applications become legacy applications over time. They have to support standard and heterogeneous infrastructure. We talk about software-defined storage running on standard servers, but over time, any given customer is likely to use different vendors' infrastructure. So we need not only to support standard infrastructure, commodity infrastructure, but that infrastructure needs to evolve on its own based on the business needs of the customer. New use cases are always coming out. So a customer might be able to derive some business advantage by going after a new use case, and there's a first mover advantage. You can't re-architect a software-defined data center as those use cases emerge. The data center must adapt to those new use cases. I need to be able to use the various deployment technologies, whether it's bare metal, virtual machines, containers, not just one of them or not just in sequence, but all of them at the same time. And finally, going back to the notion of data, the data center is about the data. The storage is about being the steward of that data. The data has to always be there. It has to always be there in time, and it always has to be there with perfect integrity. As Don mentioned, software-defined storage is hard. The goal is to be boring. And I'll talk a little bit about how in this very dynamic environment of a software-defined data center, we try to make that experience of deploying, managing, scaling, all of those aspects of storage, we try to make that very easy to integrate in the software-defined data center, i.e. to be boring. So next slide.
And Hal, as we transition, I want to make sure I caught something straight. You said you've evaluated 16 different technologies?
So I've personally worked as a CTO for companies like HP and Western Digital on 16 different scale-out software-defined storage architectures. So, I mean, software-defined is they ran on commodity infrastructure. Datera is my 16th.
Right. Okay, that makes sense. And there's even more when you consider all the virtual storage controllers that have been out there from, say, my old firm and many others. And you don't classify that in the same bucket as what we're talking about here.
Well, no. So all of them might be labeled software-defined. The question is how we're different, and I'll go into it on this slide.
Yeah.
So there's kind of three key areas that I try to talk about Datera's differentiation. First is it's a policy-driven environment. So what I mean by that is the customer says, here's what I want the system to do, and the system then adapts to that want. And those wants can change at any time, and the system will constantly adapt based on the customer's changes, the resources within the system changing, either through scaling or perhaps through failures, and through optimization. So we have an analytics environment that we collect telemetry from, and it analyzes that information and can then say, here's the sort of things that your environment is doing, and here's maybe how you could change to get better performance, better resiliency, handle additional tenants, those sort of things. So at the very top is this notion of being driven by policy. So part of being boring is you don't have to understand how the internals work in order to get the value of the system. And so being policy driven lets the customer express their requirements in their terms rather than the terms that the system uses internally. The second key thing is how data is placed within the system. There is always the notion within the system of my current placement algorithms and a future set of placement algorithms, because these systems at scale in large data centers are always changing in some way. And so there's this ability to say, I've got a current placement approach and I'm encountering this change, and so I need to be able to adapt the placement of the data to that changing environment. And you can optimize for things like cost or performance, resiliency, and it's very important to understand that the way these algorithms work, it also allows us to deal with the adoption of new technology, to deal with scaling events, either scaling up or scaling down, distribution events, moving data from among different data centers. All of those things are part of how data is placed within the system, and this common mechanism of a current and future placement approach allows us to deal with all of those things in a very elegant way. And finally, the software-defined storage shouldn't require the performance of the system to be compromised. So we have some of our key architects that came from other disciplines like processor design, distributed systems, a lot of things like Google, and they borrowed some of those capabilities to radically reduce both the amount of communication required in the scaled system, as well as the amount of I/O that's required to the back-end infrastructure. And those two things allow us to deliver a very, very fast, high-performance system with a total path length, data path length, which means how much is the software impeding the progress of the data to getting to the media of less than 40 microseconds. So policy, placement, and performance are kind of the three key differentiators. But the most important thing is the customer can change their mind at any time. They can change the policy, they can scale the system, all these different things that are naturally going to occur in a software-defined data center as I add clients and tenants, as the system grows, as I change my mind about how much performance a given application might need, the system will automatically adjust. All the customer has to do is say, I've changed my mind on the policy, I now want these different attributes, and the system will adjust to those new attributes.
Mm-hmm.
So next slide.
So,
any questions?
Well, hang on. Before we move on here, so let's get Don involved, because Don, you've been pitched by everybody in the industry before, and now you're entrusted by large organizations to help them sort out all the folks that are out there. So you've been really clear in our conversations about the need for making this automated, and that if you can't do that, then you don't pass go, because it gets back to exactly where you were before. The OpEx and CapEx you have to get value on both equations. So talk a little bit about, as you've traced the evolution of what's been out there in front of you, what you've come down in terms of where you prioritize these capabilities.
So I'll use an analogy or a corollary in the industry right now. I mean, right now when we talk about networking, used to be all about feeds and speeds and latency and all of the minutia of networking. And now when we talk, and we still do talk about that in the networking space, but we now talk a lot about intent-based networking and making sure that the automation can drive the user's intent all the way through down to the hardware. And that's very much what Hal is talking about here on a storage side, the storage side. And we're from not just Datera, but we're seeing a lot of industry movement towards this policy-driven storage environment where the individual storage administrator doesn't know where bits of data are in the infrastructure. What they do know is that, and they trust the system to have implemented the policy as defined in order to deliver the quality of service or the data protection or whatever policy the organization has decided is important to them. And I do definitely see a trend toward this in the industry where the infrastructure is going to be making those detailed decisions about exactly where things are placed.
Yeah, that's a good point. And I know we can go to the next as we do. Policies for a long time, and I've seen this for 10 years, it was very much of a replace the manual actions with just automation of those manual actions. But it was pretty rudimentary. Make 3 replicas, put them here, 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 as opposed to serve a quality of service level that you want to achieve. That's a different kind of policy, and that's been a real evolution in the industry.
Yeah, if we go back to the previous slide quickly. So most of the architectures I've worked on in the past, the architects would start at the bottom of this drawing and work up, meaning they would say, how do I build a fast system? How do I place the data to enable that fast system? And then how do I manage it? And in the software-defined data center world, that's the reverse order, right? What you have to do is say, how does the software-defined data center, that overall orchestration of that environment, want to interact with my system? How do I then have an architecture internally to manifest that policy-based approach? And then how do I deliver the appropriate performance given how data is placed and the policies are administered? So at Datera, they very much took this, let's start with the outcome of a software-defined data center and build a storage system that delivers that outcome, including how data is placed and how we deliver performance. So that was, one of the things I got excited about when coming to Datera was that approach of not saying, how do I replace a storage appliance, to how do I build storage for the software-defined data center. So,
got it.
Next slide. So here's a little bit, we're going to just go very quickly on kind of how this is built. In the upper right, what you see is what you get out of normal scale-out systems, right? You can orchestrate them, you can administer them, typical scale-out shared nothing approaches, so that as you scale, you get things like improved performance, higher capacity, increased availability, and there's this notion of high availability, what we call continuous operation. And in classical systems, that meant I can recover from failures and maybe I can upgrade the software while the system is operating. Datera has advanced this notion of continuous operation by being able to adapt to new technology. Not just saying I can wheel in a whole bunch of NVM, for example, but saying I can add just enough NVM to improve the performance of a key application. I can add additional services. I can add file services or object services. I can add perhaps database as a service. Those sort of things where as the need for moving the application in closer and closer to the data, we can add additional services. Again, non-disruptively, we can remap data to different locations. All of those things I can do while the system is operating. I can adjust the policy. I can scale up or down. There's also a key notion of what we call asymmetry and heterogeneity. Systems evolve over time, and if I impose a requirement on the customer that the system has to evolve over time in the way that the system was initially installed, that's really broken. Right? I need to be able to say, I've got new types of technology that I want to add, whether those be in the media, whether they're in the data services, whether they're in networking. I need to be able to embrace that, and in just the amounts that make sense. I shouldn't have to add, a petabyte of a new technology if I only need, 100 terabytes. I just need to be able to enable that asymmetry and heterogeneity, and Datera has done that. So next slide.
Hang on, there's a quick question here, Hal, before we move, which was that one of the audience members is implemented a scale-out object product. I'm not going to name it. A different space than what we're in, but every node for that system needs to be the exact same. Is that something that Datera has to do? Is the question. I want to make sure we answer it.
Yeah. So great question. So when you install a node in a Datera cluster or a Datera system, it interrogates that node for the resources it has available. And our distributed control plane then maps those resources into the existing policies of the existing applications, and then can allocate just those resources. So it could be, I've installed a new node with lots of resources, maybe some that I've never had before, or it could be, I've installed a very cost-effective bulk storage node. I only need to install one node, and the system can take advantage of the resources that node has. A very interesting example, let's say I've got a very important application to my customer, and I want the best performance available for that application. If I added a node that had, let's say, a new technology, maybe it's something like Apache Pass, or maybe it's something like Optane, and the control plane will recognize that node and say, oh, I've got some very fast resources. I'm going to automatically, because the policy is set that way, give those resources to those applications that need that performance. And all of a sudden, without the customer having to do anything, the application performance will improve based on adding just one node of those resources. So hopefully that's maybe more of an answer than you wanted.
No, that's useful. It seems like that was endemic of software-defined Gen 0 and Gen 1 of have node consistency so that you don't have to be able to interrogate those nodes and understand what's actually happening there. But that's the old way of operating.
the historical architectures have said, if you add a new type of node, I have to add them in some number, let's say 8 or 5 or whatever that number might be. And why is that? Well, it's because they required that symmetry in the system. And again, I think that's a drawback of many previous architectures. So next slide. So we're running out of time here, but I'm going to go through the next couple of slides really quickly. So unlike most architectures, our distributed control plane is the brains of the operation and plays a much larger role in the operation of the system. The distributed data services, this is really our data path, is kind of the muscle of the operation. It makes sure that data gets where it's supposed to go very, very quickly. And then the commodity infrastructure, this is that standard infrastructure that is available from a wide number of vendors. It kind of fuels the operation, right? It provides that physical world, provides that fuel for our system. So go to the next slide. So starting with the control plane, it kind of is, again, the brains of the operation. It discovers and configures, it does all those sort of things. But most importantly, it converts this notion of application intent to a set of maps it gives to the data plane for execution. And then it constantly monitors that execution through our cloud analytics, our insights analytics. And then it will provide new maps to the data plane. It can provide various hints about data distribution. It can provide all that. It's a much larger role than a control plane normally plays. The data services, this is our data path. It implements those data services, a block, object, file, whatever things we may choose to do in the future. And it is the high performance distribution layer. It provides a foundational block service, but and it is the IO path. But a key thing is there is no distributed lock manager. Those are the things that have historically gotten in the way of many previous architectures. And then the infrastructure layer is interesting. It collects telemetry, provides that back to the control plane as well as to our analytics environment. But it is where a lot of the algorithms are implemented for things like deduplication, snapshot, tiering, compression, encryption. And by doing that, we can scale the system linearly, and we can use algorithms that are appropriate for the infrastructure that's available. I might have a different dedupe algorithm on an all-flash node than I might have on an Optane node. Because of the resources available there. And so it gives us that flexibility. So now, in terms of the Datera architecture, I want to talk a little bit about the workflow that happens within the system. So the application service level objective comes in to the distributed control plane and is converted into a set of maps that are given to the data plane. That's the policy management arrow that is given to the distributed data services plane, which is really our data path. And then that is used to route the data, which is the execution of the policy, to the commodity infrastructure. As those operations are completed, telemetry information is gathered by the infrastructure layer and passed to our cloud-based analytics environment, as well as back to the distributed control plane to create a closed-loop system that is always monitoring the execution and the policies to make sure that we're delivering the optimal experience for the customer. So this architecture is quite different than most in the fact that the role that the control plane plays is much larger in delivering the overall experience and also provides that policy-based interface for the customer's environment. And it's really this policy-based interface that creates what Don might have referred to as boring storage, right? It does what you want with little fanfare, and it's always adjusting based on the needs of the system. So next slide. So I wanted to propose some requirements for the next generation software-defined data center. And a little bit about what I think Gen 1 software-defined data centers were able to do, and then how Datera operates against those requirements. So one is supporting the legacy, current, and future applications. The key here is I need to be able to support a range of environments, and those environments are going through change. There's also the notion of automation. Automation is a given in a software-defined data center, but you also need predictive operations. You need something that's looking ahead and saying, I think you're going to need more or less of something. You're trending towards a certain outcome. Is that really the outcome you want? And what this really does is it gives the customer the ability to change those policies proactively rather than reactively. Of course, automation is how those policies, those changes are going to be instantiated, but really you need some ability to predict what's going on based on the operation of the system. As code provisioning and management, no more manual processes. Nobody wants to sit in front of a screen, clicking through menus. Really what they want is an automated and predictive operation that's implemented through software, through code, integrated with higher level orchestration environments. You need the service level agreement driven by policy, not process, meaning I don't want to have to submit a ticket to make a change. I just want to change a variable. I need to be able to make those changes without disruption and without risk. So without disruption sounds good. Without risk means the system was designed from the outset to make those changes without disruption, thereby reducing the risk and perhaps more importantly, increasing the confidence. I need to be able to exploit new infrastructure, new technology, and new use cases. What I mean by new infrastructure is maybe I deployed a new data center and I want to be able to move some of my data over that simply by changing the policy. Maybe a new memory technology is coming out. I want to be able to adopt that new technology without having to do a bunch of offline data migrations. And then new use cases. Maybe I've got a use case that demands more performance or lower cost infrastructure, and I want to be able to do those things easily. I really need to embrace the notion of data centricity. Data and metadata not tethered to one application. Things like object storage are great for this. We talked earlier about how object storage, high performance object storage is coming to the fore. But really what object storage does is it allows many applications to manipulate and access the data. And then there's the notion of, I need to embrace the data where the data is. When a customer says, where's your data center? The real question is, where is your data? And we need to embrace an architecture that allows that data to be where it makes sense for the business, not where it makes sense for the infrastructure. What I'd argue is the Generation 1 software-defined data centers really didn't do well on many of these modern requirements. And Datera was architected from the outset to deliver on the promise of these requirements.
Yeah, Hal, one of the questions that just came in on this was, in order to be able to do this, if Datera is trying to accomplish this with a software platform, what is it that the system does or requires in terms of hardware in order to be able to guarantee the successful operation of a data environment, to these parameters and the abilities that these customers are looking for?
Yeah, so great question. So first is we have a hardware compatibility list. So what that basically means is over time, customers have come to us and said, can you support this hardware? And the answer is we can support almost any commodity hardware. It's a very, very quick process for us to say, is if you gave us a new platform to say, yes, we can support that, or we need this configuration. We might need some firmware settings, those sort of things. The key point there is we work with a wide variety of vendors. If you really want to, you can purchase the hardware from us. That creates more of a complete solution experience, which maps to the buying patterns of some customers. Or if you have a qualified vendor, we can work with them, and chances are we already do. The hardware compatibility list consists of many of the vendors in the industry that our customers use, so there's a good chance that we already support what you want, and if not, again, it's meant to run on commodity infrastructure. We can demonstrate very quickly how we can support new infrastructure.
And yeah, that's great. And I think a related piece of it is that, one question came in and talked about sort of the old way in which the array vendors were thinking about themselves. How can you use a virtual controller to stitch together a bunch of existing array-based environments? Is that something that Datera does, or is that even a good answer to the problem that they're trying to solve, which is elimination of these silos? Maybe you can reflect more broadly on that question.
Yeah, so So we used to have these things called storage virtualizers, right? They would take an array from EMC or 3PAR or whoever it might be, and add a software abstraction layer above them to stitch them together, perhaps. I've seen a number of those architectures. I've yet to see one successful, but not for the reasons people might expect. Normally, what you're doing is stitching together old infrastructure that is very, very expensive. And it is oftentimes a better idea to take a migration event onto new infrastructure that might be much lower cost than just the service on the old infrastructure. The service and support contracts on old infrastructure are how these companies make their money. And oftentimes, and we've had a concrete example of this, where a customer was able to actually save money by buying a complete Datera system and moving their data over to it than just the service contract costs of their aging infrastructure. So it could be possible. I'm not a big advocate, and currently we don't support stitching together legacy arrays.
Yeah, another problem that I've seen from my past as we move to the next is that this winds up creating not just one but two storage operating systems. So now you got to know both in order to make it happen.
Yeah. And so what I might suggest is people that are looking to a software-defined data center, that they really kind of have to let go of the old, I buy my servers and storage and I implement them in a physical data center in a physical sense with lots of manual processes, those sort of things. The next generation software-defined data center is really about how do I exploit commodity infrastructure? How do I create business velocity through very agilely being able to scale that infrastructure, deploy new applications very, very quickly. And if I bring old technology into that, scaling that software-defined data center is going to be fraught with manual processes associated with those arrays, all those sort of things. So I'm not a big fan.
Okay. Yeah, I think the question that also came in was a follow-up on, the adoption that's happening in the industry in HCI and where that works, in terms of use cases, and where that just creates yet another silo, another legacy infrastructure on the come. So what are your thoughts about where and why to use HCI?
So I think there's a role for HCI in environments that are very well understood and will encounter very little change over the life of that infrastructure. So there may be applications that a customer has written themselves that they know exactly how to fit into a very specific physical configuration that HCI provides. But if I think about the software-defined data center, part of the point of the software-defined data center is it's very agile. It embraces the notion that applications come and go and individual applications change, and what they will then need is different resources. And so HCI struggles in those sort of environments because it is intended to be very simple to manage, simple to deploy, because it's very well constrained, very well understood. And so if a customer's environment matches that, that's great. I actually think the software-defined data center is kind of going in the opposite direction.
Got it. That's the end of our questions for today, Hal and Dawn. Thank you both for everything. If we can click to the next, please. We're going to wrap up here, and we'd really encourage you to leave your feedback. So please do provide that, because that helps us tune these so that we do a better job to make best use of your time next time. And we will have, there is more, if you click to the next, there's more information that's available on our Datera.io website. You're welcome to contact us. And if you have any requests for information, we saw several requests for the slides from today, thinking about requirements, helping people assimilate those. We'd be happy to help you with those. And again, we really appreciate you taking part. Please do your best to give us a rating, and we'll look forward to seeing you next time. And thanks again to Dawn and Hal for all their insights today. With that, this is Datera, and we appreciate your time very much. Take care.